Good evening, dear students. Today we are going to learn about how to separate different components of a given mixture. Okay, even what kind of mixture it may be, whether it is homogeneous or heterogeneous, which technique we shall use. Say we have learned in mixture there are broadly two components. Either it could be solute and solvent, or it could be dispersed phase and dispersion medium. So at least these two components have to be separate, and that we have learned. In mixture, these components do not combine chemically, otherwise they could form the compound which cannot be separated. Okay, so for the separation, what are the various techniques used that we have to learn today? So separating the component of a mixture. So this component of a mixture means what? We want to separate the solute from the solvent, or the dispersed phase from the dispersion medium. That is to separate solute right here from solvent. Example, if you take the solution, any kind of solution, say salt in water, this salt is
Evaporation.
the solute and this water is the solvent.
Solvent.
So how to separate this solute from the
Evaporation.
solvent? Yes. So this is the solute, means salt is the solute and water is the solvent. So which technique we shall use, those things we have to learn. So here we are knowing that the characteristic of water is that on heating it gets vaporizes, but the salt do not vaporize. It is the solid, so it remain deposited or remain collected in your utensil in which you are heating. So this will get evaporated and this solute cannot vaporize. Therefore, the technique called evaporation is used. So the technique of separating these two is called evaporation. So evaporation can be used for separating this salt from the water. Similarly, there could be many kind of solute and solvent. So what are the various techniques that we are going to learn? Okay, student. So first thing is either this one or the second. It may be possible that there is a dispersed phase from dispersed medium. So it is dispersion medium. Medium. So how to separate these things? For that, depending on the certain characteristic of solute and solvent, the various techniques are selected. So right, depending on basic characteristics, basic means the important characteristic, difference between different components of a mixture, suitable separation techniques are used. Suitable separation method or technique, TCHNIQUE, techniques are used. So student, what are these suitable techniques and what are the important properties? Those things we have to learn. Here, I have taken one example. If there is dissolved salt in water, then the water have the characteristic that it will get evaporated on heating. Means though evaporation occur at the normal temperature or vaporizes on heating, but the salt do not vaporizes. Okay, therefore evaporation technique is suitable. In the similar fashion, if there is suspension whose particle size are quite bigger than the medium in which it is dissolved, so filter paper can be used. So filtration is other technique. So this way there are various techniques. So depending on the characteristic, the various techniques are used. What are these various techniques? So let me enumerate with the example. So example. So I'm going to write the process or technique, method used. So student, you also please write it properly. So what is the method for separation? The next, we will write its example. And other remark that I will write. In this remark, I will write the principle on which it is based, this thing. The very first process, which is quite common, is the filtration, or even sedimentation is also there. If the particle size is quite bigger, which will settle down. If the solution is left undisturbed, then sedimentation can also be used. So it is that one. The very first is your right. That one also.
Sedimentation.
Yes. Sedimentation. So for which category of mixture we can use this? Student, can we use this for solution? Colloidal solution, alloy, suspension.
Suspension.
Good.
Suspension.
So this can be used for
Suspension.
in suspension. Whose particle size is quite bigger. So if the bigger sand particles are there, and if you leave the mixture undisturbed, it will settle down. So right, what is the principle? So principle use is heavy particles settle down. So right,
that the particles settle down.
Heavy particles
Settle down.
settle down. This is the main principle. While the lighter particle will come ever. It is quite common. The first one is this one. Now let us write the second one. The second one is filtration. Many a time we have used, and even earlier I had also drawn the figure. If we use the filter paper, then this filter paper have a small hole, and if the particle size is bigger than that hole, that particle cannot cross that filter paper. But if the other particles is of the smaller size, that will cross the hole. So this is also useful for suspension.
Suspension.
Like your sand in
Water.
yes. Can be used for this milk? No, because
No,
milk
sir.
is a
No.
colloidal solution that
Colloidal
appears as
solution.
homogeneous. Can we use this for the true solution? No, we
No,
cannot,
sir.
because their
Because it is dissolved.
particle size are quite comparable to the medium size. So both of them crosses. So what is this? So filter paper.
Heavy particles are left out and the smaller particles are filtered and goes down.
It is not based on the heavy particle, it is based on the pore size or hole size.
Yes,
Okay,
sir. Larger size particles.
so this filter paper allows the smaller size particle to cross or to pass, but restrict or stop the bigger size particle. The size particles. So student, this bigger size and smaller size are in comparison to the whole size. That you have to keep in mind.
Okay, sir.
In comparison to whole size. In comparison to pore, that hole is called as pore.
Pores.
So pores are nothing but the smaller fine holes present in the filter paper. Pore or hole in filter paper. Okay, student. So this is important. So filtration is one of the important technique, so that we have to keep in mind. Huh? So do not forget this. It is most common for this sand in water or the
And in water.
yes.
Chalk powder in water.
Yes, the chalk powder means the insoluble solid, insoluble solid in liquid, because the liquid will pass through the filter paper, but the solid will not pass. The example I have taken this one. So this is the important thing that we have to keep in mind regarding the filtration. Okay. So second technique was this one. What are the other technique? Let me enumerate the third one.
Sublimation.
So the third one, the most common is evaporation. Whatever I had explained just a few minutes back. Right? That evaporation. So this evaporation is suitable for that kind of mixture in which one of the component get evaporated on heating or at the normal temperature, while the other do not evaporate. Right? So for mixture having one component volatile. It is called as the volatile. Okay, one component gets evaporated or gets vaporizes or evaporated on heating, but other do not. If the both components are able to convert into vapor, then this technique cannot be used. There we have to go for the other technique called distillation, where evaporation is one of the part. Okay, student. Example. Let me write the example.
Salt in water.
Yes, the best example is salt in water. So this technique is used for preparation of salt. So question is asked like this: which is the technique used for preparation of salt from the sea water? So this is the evaporation from
Evaporation.
sea water. Okay, so we can use for this mixture. What is the principle? The principle is evaporation of only one component.
It one component get vaporizes.
Yes, yes, yes. Just wait.
Heating.
Please write. Evaporation of only one component. So this we have to keep in mind, while the other component remain
Settles down.
undisturbed, okay, or remain collected in the utensil. Okay, so that's why it is only
Yes.
one component. This is the example we have written. Okay. In addition, this evaporation is also useful for separation of this ink, say drying your ink. Okay, so if you are heating the ink or dye, what is happened? The water present in that ink will vaporize, but the
Evaporate.
dye or the colored component, blue color or black color, will remain collected in the china dish. Okay,
You can say.
so right, it is one that we have taken this example. Write down the second example also. The example 2 is
Separating
your
ink.
blue and black ink. So blue or black ink means ink components. This ink component contain even the water or the liquid. This liquid will vaporize, but the solid present in this solid will remain collected. Okay, this will not vaporize. So this we have to observe. Okay, student. So these two are the important example that you have to keep in regarding the evaporation. Now let us go for the fourth one. स्टूडेंट एक बहुत ही कॉमन है, हम जस्ट नेक्स्ट आपको इसका एक फिगर बना करके आपको दिखाएंगे. लेट मी फर्स्ट समराइज और लिस्ट और टैबुलेट ऑल दिस टेक्निक्स ताकि आपको इजी रहेगा. द नेक्स्ट वन इज
Centrifugation.
yes, the fourth one, let me write in the this. So the next technique that we are using is centrifugation. was the third one. The fourth one is called your centrifugation. Centrifuge or centrifugation mean the same thing. So this method is used for separation of those mixture which are either colloidal solution or true solution, where both solute and solvent particle size are comparable, nearly of the same size, but their masses are slightly different. So, right? It is for nearly same size particles. So, for same size but different mass. Example, there are so many. A student, the cream from the butter, from the milk that is obtained by.
Cream from milk.
So write down the first example, cream from milk.
Sir, separating blood.
The next one is the butter that you can obtain from the cheese.
Sir, can we take example of blood?
Yes, it is also that I will also write. So even in blood test and urine test, this technique is used.
In washing machine also.
Yes, that is the best example that we are observing practically. So in blood and urine test. So whatever pathological tests that are conducted, it is by the process of centrifugation. So different components of blood like WBC, RBC, they have different masses, so they get separated. The fourth one is your washing machine. In this, the water splices or remove the dirt by this centrifugation. So what is there? Again, the heavier particle, here the mass is different. So because of this mass difference, the heavier particles settle down. Here the size is same. Okay, so wherever the filter paper cannot be used, there this centrifugation can be used. Right? Heavy particle move downward but this is not for the undisturbed condition when the solution is spun or rotated or disturbed, when the mixture is rotated, like we are observing in our washing machine. Okay, so this can be used where filtration technique cannot be used. The filtration is also based on the mass difference, right? It can be used where filtration cannot be used. Why? Because of the same mass, the same size, these particles are able to pass through the filter paper, but because of their different mass, they will settle downward while the other will continue to float. at same size. That is the main problem. So this is the centrifugation. It is very important technique. The next one is, let me write the sublimation. A student, the sublimation is nothing but heating two solid mixture in which one of the solid mixture get converted directly from the solid state to vapor state without going to liquid state. Okay, so only there this can be used. So right, so for volatile component, example, if the salt contain,
Camp.
just if the common salt contain ammonium chloride or camphor, then ammonium chloride get vaporizes into atmosphere, but the common salt remain as it is. Okay, so right, ammonium chloride, like this, ammonium chloride from common salt. Common salt is what? Our NaCl. This is NH3Cl, but whatever the common salt that we are using is NaCl. Okay, so both are the salt, but this get vaporizes while this will remain as it is. Okay, so this is the volatile component. So the technique that is used, this process of conversion of solid directly into vapor without going to liquid is called sublimation. Sublimation, where one component converted to vapor without going to liquid. To liquid phase means if you heat this, it will not get converted into the liquid, it will directly get converted into vapor. The other example are like the dry ice, the camphor. It's really exhausted, or what is this exhaustive? हाँ बोलिए. आई एम ऑनलाइन, तो आप बोल सकते हैं, आपके चैट हमें दिख रहे हैं. यू पीपल आर चैटिंग among yourself.
नहीं सर, मेरा नेट तो ये नेट खत्म हुआ है, बहुत वॉइस फ्रैक्चरेशन रचीले बोला आपने.
ओके, नो इशू. आप लोग को जरा अपना ध्यान रखना चाहिए. ओके, जस्ट अनदर 5 more minutes वी विल टेक द क्लास.
ठीक है सर.
डाउन कर लेंगे. सो अनदर इज कैम्फर. Another is the naphthalene. The third one is the naphthalene ball that you are using. So this thing can be purified. It is this method. The next one is, let us go for the sixth one. The next one is called the common separating funnel. separating funnel, but it is nothing but a kind of test tube in which at the lower end a stop cork is fixed with a tab so that two immiscible liquid can be drained. Means one of the immiscible layer can be drained slowly. So this is used for two immiscible. Do you know miscible and immiscible? Like if you add the large amount of oil in water, what you will observe? The water will form a separate layer and the oil will form separately. The water will be at the bottom layer and the oil will be at the top layer. Okay? So if a cork is fixed at the bottom and if we open it slowly, then this water will drain down and oil will remain in this separating funnel. So it is used for two immiscible liquid, EMMI SCIBLE, immiscible. This you have to keep in mind. Liquids means they are not able to intermix. ऐसे वाले को इनकी दो अलग अलग लेयर फॉर्म हो जाते हैं. तो टू सेपरेट layers of liquid are drained carefully. तो इसे ध्यान से स्लोली कॉर्क को ओपन करके इसे हम निकालते हैं. द एग्जाम्पल इज what large amount of oil in water. Say
Oil mixed in water.
yes sir. So it is large amount of oil in water, but it should be in larger amount. Just थोड़े से यदि ड्रॉप्स हैं तब आप इसे सेपरेट नहीं कर सकते. So it is in large amount. Say example. अब दूसरा oil या kerosene is also a kind of oil. Kerosene oil in
Petrol.
water. Yes, it may be the petrol also. The next one is the seventh one technique is called distillation. So before that, let me write the chromatography. So
Different colors.
so the term like chromo, it simply means color. Okay, means different color component can be separated. Component. Example, if the dye contain different color, the different components can be separated. Say the green pigment that we are obtaining from the flower, so
Drugs from blood.
pigments, yes, the blood component like red color, RBC and WBC and plasma, they also get separated. So blood, RBC, okay, it is the RBC that will get separated. Okay, it is this one. What is the technique? The technique is that this chromatograph is nothing but a kind of paper, and on that paper the different colored components are able to move at different rate. Okay, so different solubility, it is called as the solubility. Different solubility, that is more soluble component moves faster on chromatographic paper. So there is a special kind of paper called chromatographic paper. So this paper meant that. The next technique that we have to keep in mind is the distillation and fractional distillation. So this distillation is used for two miscible liquid. This separating funnel we have used for immiscible, means those liquid which are not able to intermix. But this distillation can be used for two or more miscible liquid. What are the example? Example, the alcohol is able to mix with water. The important thing is that the two miscible liquid must have different boiling point. So two miscible liquid boiling point difference. So melting point, boiling point, hope you might be knowing. Boiling means when you heat it at the temperature at which it will start boiling, converted into the vapor. Boiling point difference is greater than 30 degrees C. So this difference you have to keep in mind. There is another technique called fractional distillation. That is also a distillation, but when the boiling point is not greater than 30 degrees C, for that liquid we can use. So write that fractional distillation. These are the key things that you have to keep in mind. Okay, student? तो आप इसे जरा बिल्कुल ही मन से ध्यान में रखें. So it is also for miscible liquid but whose boiling point को मैं BP लिखता हूं, difference is even lesser than 30 degrees. यदि बॉइलिंग पॉइंट का डिफरेंस 30 डिग्री सी से कम है तब हम इसे यूज करते हैं. एग्जाम्पल, आप एसीटोन इन अल्कोहल ले सकते हैं. इसके अलावा इट इज नॉट लिमिटेड टू दिस वन लिक्विड ओनली बट आल्सो द गैसियस मिक्सचर. आल्सो फॉर द गैस और एयर. एयर के डिफरेंट कंपोनेंट्स है. So it can be used for the liquid as well as for the gas. Air contains oxygen, nitrogen, hydrogen, carbon dioxide. So each of these components can be separated. So air. Here the main difference is that here we are using one fractionating column in addition to the setup of distillation. So what is the setup of distillation? This we will learn tomorrow in our next class. So it contains fractionating column.
Sir,
Yes,
the fractional distillation temperature should be greater than 30 degree or lesser than?
it should be lesser than 30 degrees. Okay?
Okay.
But for this distillation, normal distillation, it should be greater than 30 degrees. Okay? So means the distillation in which the temperature difference, the difference in their boiling point is less than 30 degrees C. There it can be used. Okay, the liquid are also miscible. So this is all about the different separation techniques. I hope now we shall stop the class. Next day we will continue. So whatever we have learned today, you must remember all these things. What are the various example? What is the principle? These things you have to keep in mind. So this table, you please go through this table again and again. Okay, student? आप इस टेबल को दोबारा तिबारा आप देखिए